Hello and welcome back to my workshop. My name is Robert. I was contacted by one of my subscribers asking me if I'd be prepared to make a gear for him to enable him to fix a milling head that he has that he's restoring. This is the gear in question, so clearly I've said yes. So this will be part one of two of making this gear, going through all of the steps from making the tooling, the mandrel and so on, to actually cutting the gear. So I hope you find this interesting. Let's get on with it. This is the gear I've got to replicate. As you can see, it's got some significant damage at the front edge, probably due to changing gear whilst the milling head is under power. So it's 20 teeth, it's 2.2 inches in diameter, I believe. Yep. So that makes it a 10 dp gear, and more than likely 14.5 degrees pressure angle. So I'm going to remake this in EN8. So to make it, I'll probably make two together, so that I've got one that I can mess up and one to be the final article. I will cut the keyway on the shaper and then mount it on the mandrel to turn the OD of the gear, then onto the mill where I will gash the teeth with a slitting saw. This makes life much easier for the shaper. Then all the shaper has to do is to put the curves on the teeth rather than remove the bulk material through the middle. This is the slitting saw that I sharpened in a previous video, and it fits very nicely down in the root of the teeth. I manually rounded off the edges, see that, on a grinder, because I don't really want square bottom to the teeth. This is the chunk of material that I'm going to get these gears out of. There's plenty there. I'll chop it off in the bandsaw. Just to show you how spacious this workshop is. There's the bandsaw in the corner. There's the tool chest that has to shift out of the way. Got the tool and cutter grinder there, and the Taylor Hobson lathe in the way. And the mill is somewhere at the back. Spacious. Okay, this drill's a little bit too short, but it's the only 1-inch drill I've got. I'm going to attempt to rough out the material with this. We'll see how we get on. 125 RPM. Okay, before I take this out and spin it round, I'm going to rough in this section here, which is about 1 5/8. I flipped it round, it's back in the 3-jaw, so it's not going to be running perfectly concentric, but then there's plenty of allowance on everything at the moment. So we'll face this side and drill this side to clean out this 1 inch all the way through. Then we can attack it with the boring part. So before I carry on too far boring out this pair of gear blanks, good time to actually find out exactly what we're after and double check everything. So first things first, there's a 1 inch gauge block, and I'll just use this to check my micrometer, and it may not be bang on, but it's within a tenth or so. So next, the gear rides in this area here, and this shaft has about a thou under there. Yeah, it's about a thou under, just about 1 thou under all round. So that looks like that's at 1.124. Now this gear is a nice tight fit. And that's the fit that we'll be looking for. I'm getting about 2 or 3 thou over. Just try this in several places until that's a nice fit there. It's a bit tighter in that location. I'd say that was about 2 thou over. It could be the key making it very tight. Let's try it from this direction. Sloppy fit on there, really. Personally, I'd rather it was a smoother fit on the spindle and less reliant on the key to keep it tight. There's 45 thou left to come out of this bore now to bring it to 1.125. I think we stop playing at this point. Okay, well, it's here in the lathe and that bore is guaranteed to be concentric. There, I'm just going to face off this outside and I'm going to take this shoulder down to 1.625, 1 5/8. Right, that should be there. Let's break some edges and give it a bit of a polish, and this face is done. Where the bandsaw takes over. I'm going to use my shaper to cut the keyway in the blanks. Now to do this, I'm going to have to remove this tool holder here, as it's not going to be appropriate for what I need to do. So I'll just slide that out. And I'm going to replace it with this, which is a homemade fixture which will hold a bar, and the bar will then hold one of these little cutters. So first things first, let's just pop that through there. The threads are a nice tight fit in the clapper. And we'll whiz the nut up and just roughly secure it for now by hand. I'm going to straighten up the clapper box. It doesn't actually make any difference for this. So that will be nipped up. And then the next thing to do is to secure this screw. This is not an original fixture on a 10M. This is something I've added. The screw basically goes, it's got a thread in the outside piece of the clapper and a pin on the end of a dog on the end of the screw goes into a dimple in the clapper, and the clapper is now locked. If we don't lock the clapper, there's a good chance that the tool is going to, as it goes through the work, it's going to ride up, and then you won't get an even depth on your keyway. It does cause some tool drag on the way back down, but we're manually feeding, so we can feed down once the tool has exited the work. We won't be feeding down whilst the tool is retracting. So we now have this tool holder, which has two flats on the side, and these are used as reference surfaces to make sure that this hole is vertical. So I'll just pop that in there for now. So there's a small flat on the top of the bar so that the set screws don't mar things up and make it difficult to get it in and out. Now the tools, this is the smallest one. They have relief ground on the sides. This one's got relief ground on the front face and about 5 or so degrees relief on this face here. I have a variety of sizes. Now, the accepted way of getting the best result is to plunge straight down. If you then start moving side to side to try and widen the slot, say we use this one here to try and cut a slot which is much wider, what happens is as the bit goes through the slot, cutting the side, it gets pushed towards the middle, and therefore you get a tapered result, a tapered keyway, which then requires more dressing. First things first, I'm going to place a square along the side of the tool, alongside of the bar, and bring it up to the cutting edge, and with this just loose enough to enable this to rotate, I'm going to align the front edge of the tool to be square. Then I will slightly nip this up, hold it in position, recheck. That looks pretty good. It doesn't make so much difference on a very, very small tool like this, but it will make more difference on the bigger tools. And then we will tighten this in here. Now I've adjusted the height of the tool so that it will just go through the bore. This conveniently comes out where I can actually see what I'm doing. I'm now going to place one spanner on the end of the tool holder, and the second spanner will be on the nut. I'm now going to adjust these two spanners until this reference flat on the side is vertical according to the square. Now the way I'm going to approach this, I've got the biggest cutter in here at the moment. This one's 5/16 wide, which is the keyway I need. This is too big to take in one hit on this machine. You might do it on a bigger machine, more rigid setup, fine, but not on this machine. So what I'm going to do is I'm going to initially find center with this cutter. I can put this cutter back in exactly using the bore here. If nothing moves, if the table doesn't move, I can use the bore here and the reference surfaces at the side here to get this back in the same position. So the side to side is taken care of. I will need to take the bar out each time I change the cutter in any case to ensure that the front of the cutter is perpendicular to the direction of travel. I'm going to feed it through until it touches on one side, because it will touch on one side first. If it touches on both sides simultaneously, we'll just call it good and have done with it, but it won't. So I'll touch off on one side. I've then got a dial indicator set up down there. So I will then move across until I get the same size scratch on the other side. Note how much we have moved on the dial indicator, and move back by half the distance. So then we'll be set up exactly in the middle. At that point, I'm going to take this bar out, put the smallest cutter in, cut a small groove down the middle. Then I'm going to repeat the exercise with the next size up cutter, and so on until I reach this cutter here. I think the cutter that's just a bit smaller than this is a 1/4 inch that I've got. They're all homemade. And so we'll be taking a maximum of 1/16 of an inch on the final pass. Now by doing it this way, the cutter is always cutting on both sides of the keyway at the same time, so there's no reason for it to be pushed off to one side or the other and end up with a tapered keyway. It should be a straight keyway. I've got some marker pen in there to try and improve the contrast, both for you and me. We'll get the machine going and then gradually wind down the tool slide until it touches, and I'll wind it across. I've carefully adjusted the stroke and the position of the ram before we start to make sure that nothing's going to crash, because that would end up badly. It's on a slow stroke because the feed is manual. There. It's just scratched the line. The dial indicator's on 0. We've got a line on the other side now. and the dial indicator is reading 54, so we'll come back to 27. Which is there. Right, so now we're in the middle. So before we attempt to cut the keyway, first question is how deep? Now I'm going to measure the bore of this with a micrometer, and I'm also going to measure the bore but into the keyway, and the difference will tell me how deep to cut the keyway. Now the measurement for when we're actually cutting the keyway, the measurement won't actually start until the cutter has actually touched right in the middle. It's not when it touches on the side of the cut. So we take the measurement of that. So that's 1.128, which is 3 thou over, which actually stacks up with what I measured before. It's an extremely sloppy fit on the shaft. So if we put that on the shaft, it's not very good. And this says 1.211. We're ready to go. This cutter is not properly centered on its material, so that will do as a reference. So we'll stop there. So to get our depth, I'm going to zero this dial. There's no proper indicator on here, there's just a small punch mark that is my doing. So we should just nip that up on 0. Have it, 85 thou deep. If I'm to believe this, that says I'm about 6 thou shy. It's very difficult to get a good feel. They need an awful lot of skill to use those things properly. I'm going to take another 10 to guarantee that I'm actually at the bottom of where I want, the depth that I want. there. And that now will be my reference. The bottom of this slot is now the reference for all the other cuts that we're going to make. Tool changed, next size up tool in there. This is probably about 3/16 of an inch. Okay, 1.214. The original was 1.211, that was 83 thou deep, so this will be 86 thou deep. Next tool, this one is 1/4 of an inch. Here we go with our final pass. Final check with a 312 stack. That's a 312 stack, and that goes in quite comfortably. Now if we use a stack of a 0.1 inch, 0.1005 and a 0.112, that sort of wants to go, it's tight, that'll be absolutely perfect. So now we come to the problem of fitting the key. This really doesn't want to go in there. It doesn't want to go in the new one, either way around. And it doesn't really want to go in the old gear either. It's just too tight. I've got some 5/16 key steel here, apart from the rusty bit, and that's a nice fit in there. Possibly I'd like it a little tighter. It's about the same fit in there. And it fits in there without any slop either. So if we take this key and just mic it. It's just a shade over 8mm. That's just about there. That may be all it takes. That's a nice fit. It's not fully pushed home, but it certainly looks like it's about right. Nothing's going to fall out, so it's not too loose. It's a nice snug press fit in there. That will do very nicely.